All right. But before we see the example, we need to, still describe the step size a little more, because it's pretty complicated. Yeah. So hope you can understand. Yeah. All right. The details. Yeah. The typical situation is like this. Okay. Yeah. Now we want to do pre-calculation. So what do we calculate in our pre-calculation? All right. So our pre-calculation is independent of the text. So we don't know the text. We only have the pattern, the keywords we have. So one keyword, after we take it, we can calculate this, information. Yeah. All right. So here we define a function, T function. T refers to table. Yeah. We create a table. Okay. The T function. T of C, the character C, defined two different values. The first value, M, you can see the step size. It corresponds to the step size, M, when C is not contained in the pattern, this part. Okay? Yeah. So remember, not the whole pattern. The pattern from the first character to M-1 character. Yeah. Then the step size is M. Yeah. Second, if C is in that pattern, then we get that D, we calculate the distance D as distance of the rightmost occurrence of C in the pattern from 1 to N-1 to the last character. Yeah. That distance. Yeah. All right. So this table can be easily calculated, right? Yeah. But not done yet. We have a lot of work to do. Yeah. Now we introduce another concept called a bad symbol shift. Bad symbol shift concept. So what's that? Bad symbol shift. Yeah. So let's draw diagram, describe the typical situation. Yeah. Text and the pattern like this. Then let's look at the matching part. Yeah. This part matching, this part matching part. Okay. Then we have the first non-matching pair. The first non-matching pair. Okay, different. Yeah. So when we have that, yeah, so here the matching part, there are K characters. The length of the matching part is K. Yeah. The non-matching part, yeah, so we call this bad symbol shift because this is a bad symbol, right? Yeah. Matching part we call the good symbol, right? Good. So the non-matching part, the bad symbol. So we have this concept, yeah, bad symbol shift. All right. So when you shift this K, yeah, that K, it's a bad symbol shift. Yeah. So we call this K as the measure bad symbol shift K. Yeah. All right. Then let us use one simple example to explain this concept. The pattern BAO BAB. Suppose this pattern. Let's calculate the table. So we call it a pre-shift table. We call it pre-shift table. All right. So let's list all the characters. Yeah. So here we just use, some commonly used characters, not necessarily all the characters. All right. Then A, so look at A. What's the distance? So this is the rightmost occurrence. The distance rightmost to the last one, that's A. You do subtraction on their position number. Position number B is 1, position number A is 2. 2 minus 1, that's 1. Okay, that difference. So that 1, so we put the 1 here. Okay. For B, remember, we look for B, rightmost occurrence from the first one through the last n minus 1. Yeah, not counting the last character. Yeah. So that's why the first rightmost occurrence is this one. This one has position number 3, and the first character position number 1. That difference is 2. Okay? All right. C, we couldn't find it. So if you couldn't find it, you use n as the shift size. Okay? Then from C through n, all 6. Okay? So yeah, because you cannot find the characters in the pattern, so all 6. Then O, you can find it. Yeah, so the difference is 3. For P6, then all the way to Z and last empty space, the space also M6. Yeah. All right. So now we can calculate this table easily, right? Yeah. So then we have that situation. Yeah. All right. So when we compare, so when we see the C, all right, so we check the table, we find that number. There is a number. The table will return a number to us. Yeah. All right. So then when we use that number, we can define a distance. That distance I call a level 1 distance. Level 1 distance. Okay. So the level 1 distance we define as this. D1 equals max of T of C function minus K and 1. Which one is larger? We take that. Yeah. That's the definition. Yeah. But why this? Because level 1 distance, this D1 is a possible shift size we can use. Possible. Yeah. Shift size. So why this number gives us a possible shift size? So my next slide, I will explain it. Yeah. So in our textbook, it gives this formula, but it does not explain much. Yeah. So very, very little, so almost no explanation why this expression can give us a possible shift size. So next slide, I will use the whole slide to explain why. All right. So after we get the level 1 distance, then we get a lot of information we can use to do the shift. Yeah. But level 1 is still not enough. Then we have level 2 distance. Yeah. All right, but I need to explain this expression first. Yeah. Not my explanation of level 1 distance. Yeah. So here, I repeat the diagram, and we assume the matching part. This is the matching part. Okay. Then the first non-matching pair here. Okay. Yeah. So that is our current situation. Yeah. Now let me explain why that formula gives us a possible shift size. Based on our understanding, we should find the first occurrence of this C character, first occurrence after this character. Okay? The first occurrence after the non-matching current character. We should find that. Okay? All right, so here I call it first occurrence of C after the mismatched character. That is, this is the mismatched character. So we define that. Okay? So we need to know that position. All right. So here, let me use this T function. T sub R of C with R greater or equal to 1. R means the rth occurrence of C in the whole pattern. because the first occurrence of C may not be the first occurrence of the whole pattern, right? Because the C may occur multiple times here, right? May not be the first occurrence in the whole pattern. Yeah. So that's why I call it the rth occurrence of C in the whole pattern. Okay. So here I can write this T sub R of C as the distance of, I change the rightmost to rth occurrence of C in the pattern to the last character. I modify. Yeah, so that T sub R of C. Okay. After I have that concept, now I can do the calculation. Okay, do the estimate. Yeah. Now I need to shift my pattern in this way, right? So that C and this C matching part, they should be aligned, right? So after I align it, I need to calculate the step size. What is the step size? That's the one we could use as our level 1 distance. So this is the level 1 distance, D1. Okay, yeah, we need to do the calculation. Yeah. But how to estimate this step size? Yeah. So let me draw a diagram here. Yeah. Although even this one is matched, this part must be matching, right? This part must be, but don't worry. Okay. So when we shift in this way, we start a comparison from the first character from this place. So we will go through another time. So we will cover this part in our next round comparisons. Next round comparison, we will cover this part. So don't worry about that. Okay? Yeah. All right. So now we just want to estimate the step size. Step size equals T sub R of C minus K. Why is that? So we calculate the step size as T sub R minus. Why is that? Because TR of C, what's that? Based on the definition, the rth occurrence, the distance to the, because you minus the last character, so that's the distance. All right? All right. So here, this is K. Remember, this is K, but that is also a K. Okay? So you remove the last one, but you need to add this one, right? So that is the K. So now you can see, based on that, this step size, this distance minus this distance, right, to the same point here. Okay, this one, same point here. That's the TR of C minus K. Okay, from the diagram, yeah, because except we remove the last character. So then, you know, both cover this K characters, right? So we minus that K characters. Then the step size, the difference is the step size. Okay, all right. So we get this for our step size. But TR greater or equal to 1. The rth occurrence, R greater or equal to 1. The smallest R is 1. The first occurrence, the rightmost occurrence, right? So TR of C should be greater or equal to T1 of C. Yeah. But T1 of C minus K equals T of C minus K. Okay? Then step size is this one. But this one could be negative. Okay? Yeah, because it's possible it could be negative. So that's why we take a maximum of this number and the 1. If it's a negative, if less than 0, we take 1. Okay? Yeah. So that's why we get D1 max of this possible step size with 1. Which one is larger? Yeah. So this explains the D1 definition. D1 definition. Okay. All right. Next, new view, good suffix shift. We want to get another distance definition, level 2 distance. But this time we take a new view, good suffix view. Okay, all right. So let's look at this diagram again. So this time let's focus on this part. That is the suffix of the pattern, right? Yeah. But that suffix, because all equal, all characters in the suffix part equal. So we call it good suffix. All matching, so good suffix. So we try to match the good suffix part. Okay, all right. So let me draw the typical situation here. Okay, so the good suffix K, this part. Then one character E after the good suffix, and C and E1 different. Okay, if they are the same, we can add to the good suffix one. Okay, we can add into the good suffix part. So they should be, C and E1 should be different. All right. Then in the later part of the pattern, we want to find another good suffix part and E2 after. There is a character E2 after the good suffix part. So we need to find another matching part. Okay? So our observation is like this. First, when E2 equals E1, it's possible E2 equals E1, then we can skip that part because E1 fails. We know E1 fails. Why we try another fail comparison, right? So we don't need to try another failed comparison. Okay, so we look for E2 different from E1. So then if E2 different from E1, so we can try that. Only when E2 different from E1, then we can try that. Okay, worth another trial. Okay, so based on this observation, we define our level 2 distance, D2. D2, the C1 in the second suffix pattern minus C1 in the first suffix subpattern. Okay, yeah. All right, so that's the definition with this condition. Okay, so when you define in this way, make sure this condition is satisfied. All right, so we define a level 1, level 2 distance. Now we can, work on real example. Generate good suffix table. How do we generate good suffix table? Yeah. Here, let's use a simple example in this way. Yeah. All right, so this is the pattern. Okay, how do we calculate D2 distances? Yeah, so the definition is like this. All right, definition like this. All right. When K equals 1, we consider the suffix length 1. Yeah, so this underline, this is the suffix part. All right. Then after that, what is the first character matching this one? First suffix, you're matching the whole suffix. So that's this in blue color B. Okay, yeah. What is the position difference? 2. So the D2 position difference between these two characters, 2. All right, so that's the K equals 1. K equals 2, now the suffix becomes AB. Now, let's find another suffix AB part. Okay, so we find it, the first one. Then what is the difference of the position of the first character in the first suffix and the first character in the second suffix? 4. Yeah, so that's the distance, 4. Okay, all right. The third one, 3-character suffix. Okay. Now we also want to find a 3-character suffix in the remaining part, but we have the AB matching, but we don't have the 3rd character matching. If we don't, we just assume the 3rd part can be matched. Yeah. So we are more generous. Yeah. So here we assume, we can consider, if nothing, we can consider that part matched. Okay. So then let's consider the difference 4. Yeah. Because in this way we shift 4 characters, this part matching this part, we do not miss anything, right? We do not miss anything. Yeah. So we are okay with this view, this treatment. Next one, 4-character suffix, only the first 2 matched, the remaining 2 not matched, but we just assume they are matched, right? Because we won't lose anything, right? So when AB we put here, the remaining, we will do new comparisons. So we won't miss anything, okay? Yeah. So we can do that. So the distance also 4. Yeah. The last one, the 5-character suffix, then we also match 5-character suffix. Assume that, then the distance also 4. So in this way, we calculate the D2 distances. Another table. Okay? Yeah. After that, now we need to combine. So we need to define combined distance for our final shift size. Yeah. We have different views. Which view can give us better distance, longer distance? We will take the longer distance. Okay? Because either view works. Either view works. So we combine them. We take the larger step size so we can move faster. Yeah. So our combined distance, we will define the maximum of the 2 distances, D1, D2. Maximum of the 2 distance. But that is for k greater than 0. When k equals 0, that means the suffix length is 0. So the first character does not match. The first character does not match. So then we just use D1. Okay. We don't have D2, so we just use D1. Yeah. All right. That's the definition of the combined distance. So now we are ready to do the matching. All right. So before we do the matching, so let's review a little bit. The T-table, yeah, so we can calculate it easily because we need to use this table to calculate D1 distance. D1 distance. Use the K. So the K, meaning of K is here. Good suffix length, right? Yeah. So that's the K meaning. Yeah. So with that, so here you can see a lot of notations, formulas. With all the preparations we do here, next we are ready to work on some concrete example. So you can see how do we use the algorithm. Yeah. It's pretty complicated. Hope you can get it. Yeah. Example. Text given like that. Pattern like this. Then we determine the step size. Pre-shift table can be calculated easily like this. Yeah. So this is step, the easiest. Yeah. Then we use the level 1 distance definition like this. Okay. Then good suffix table, we need to calculate level 2 distance. Good suffix table. All right. All right. So suffix length 1, distance, look at distance 2, right? Suffix length 2, look at the distance. BA, right? So BA, yeah, B here. So 5. Okay. Suffix length 3, 5. Suffix length 4, 5. Suffix length 5, 5. Okay? So the D2 distance can be also calculated easily, right? Yeah. Now, we are ready to process matching, string matching. All right. When we do string matching, the D0 is defined in this way. Okay. Now let's work on our example. The first round, okay? K and B not equal, right? M equals 6, M. Step size equals M, 6. Yeah, not equal. Also, sorry, K, yeah, because K equals 0. Not matching, right? K equals 0. So we should take D1. D1 here, because K is 0. The good suffix length is 0, so we should take table T of C, right? Yeah. So here, yeah, let's do that. K equals 0. Yeah. So D0 equals 6. D0 equals that D1. So that D1, T of C is 6 because K is here, right? K is here, so 6. Yeah. So D0 equals 6. So we should jump 6 steps. Okay, yeah. So the second round. The second round, then let's look at good suffix part. AB, this is good suffix part. K equals 2. Okay, K equals 2, then the next character that does not match the space, D1 equals 6, because the space, T of C for the space is 6. 6 minus 2 is 4. So D1 is 4. How about D2? D2, 2 suffix K equals 2, it's 5. So D2 equals 5. 5 greater than 4, so our D0 take 5. D0 takes value 5. Okay? So our next round, we jump 5 characters. Here, our third round. Third one here, so the length of the suffix 1, right? K equals 1. Okay? K equals 1, the space 6. 6 minus K, 5, right? D1 equals 5. And D2, 2, right? Yeah, because suffix 2. So the D0 equal, take D1, 5. Because D2 is smaller. Yeah. Yeah. All right. Then, so we should jump 5 characters. Then, when we jump here, we compare one by one, so we find a match. Because we get to the right place. So we find a match. Yeah. Here you can see that's the basic idea, the algorithm. So in this way, we can get much faster performance. All right, so we complete the whole part B of lecture 9. Yeah. So next time we will start lecture 10.